Hello everyone, this is Miss Sarah. I'm back with my next lesson. I'm still on 9-4, so a few more examples on evaluating a series. So it's still arithmetic series. And one thing you need to understand when I say evaluate a series, it's same as finding sum or adding all the terms of an arithmetic series. So evaluating is same as finding sum. And I hope you remember. So for finding the sum, we have this equation. So S, which is the sum, Sn means S of number of terms or n terms, is equal to n over 2 a1 plus an. All right, kind of quick review. So I hope that will help you recalling all the information we have done yesterday. So n is number of terms. A1 is the first term, an is the last term. So pretty much you have to have three variables in order to evaluate sum of a series. So a few more examples. Okay, I just said you have to have at least three terms in order to evaluate sum of a series. So let's say something is missing. So any of these variables is not in there in the problem. Then how do we find that? So in order to find any missing information, so you have to have something to solve for that, and that is explicit rule. So anytime there is anything missing, we gotta go back to explicit rule and we solve for that information and we plug it into the sum equation. All right, so this is something you need to understand. So I'll start out with something simple, kind of easy example so that you can understand the process. So let's say I have 4 plus 9 plus 14 ... and 99. First, I need to check if it's arithmetic series or not. Let's see if it's going up or going up by the same distance or not. 4, 9, adding 5, 9, 14, adding 5. So it means, yes, it's arithmetic series. Next, do we have everything we needed? So we have to have number of terms. Do we know number of terms? No. That's missing. Do we know first term? Yes, it's 4. Do we know the last term? So last term, remember an is the symbol for the last term, or you can say the nth term of a sequence, right? So 99 itself is the last term. So yes, I do know that. Okay, so n is missing. This is where you need to go back to explicit rule first. So let's go back to explicit rule. I hope you remember how to write explicit rule. So it's an, the term you're solving for, is equal to a1 plus n minus 1 times it by the difference. So a1 is the first term, which is 4, plus n, which is missing. The difference is 5. Okay. Now, an means the last term or the term you're solving for. So isn't it this time in this problem, you already know the last term. So I just need to figure out 99 is what term of this series, right? So what I'm going to do is I'm just going to put 99 on this side because I already know my last term, but I don't know what term it is. For that, I need to use explicit rule and I'll solve for n. So let's just solve for n. So this is where I would distribute. So use distributive property. So it's 5n minus 5. It's equal to 99. Let's combine like terms. So 5n and it's minus 1. It's equal to 99. Add 1 both sides. So it's 5n. It's equal to 100. And if I solve, n is equal to 20. So 99 is my 20th term of this sequence. So I already know number of terms. I have 20 in this problem. Let's go back to sum equation. So S of 20 terms, I would have number of terms, which is 20, divided by 2. So first term is 4. My last term is 99. So let's simplify. 20 divided by 2 is 10. 4 added to 99, 103. And my answer is, oops. So it's 1030. Here you go. Let me show you one more. Actually, I have two more. So let's say I have another sequence like -3 added to -5 added to -7 added to negative 9 and dot dot dot, and I have 20 terms in this series. This can also be written as this. If you see something like this, it's the same thing, all right? It's basically simplifying those signs. Do we know our first term? Yes, we do. First term is negative 3. Do we know number of terms? Yes, we know there are 20 terms. Do we know the last term? That's what's missing in here. Again, we got to go back to explicit rule. Let's solve for what we needed. Explicit rule for the last term means since I know there are 20 terms of this sequence, so I know my last term would be the 20th term. So A sub 20 would be the explicit rule for 20th term. So A1. I hope you remember number of differences is always going to be one less than the term you're solving for. If you don't remember, that's okay. Still, I can put 20 minus 1 and times it by the difference. Let's plug everything in. A1, negative 3. 20 minus 1 is 19. And the difference, okay. Again, you should know this. In order to find the difference, you could always take the second term and take away the first term. So I would take negative 5 minus negative 3. It's negative 2. So the difference is negative 2. Plug everything in, negative 3 minus 38, and if I simplify, this is negative 41. All right, so I already have my 20th term, but that's not all. We still have to find the sum. So go back to sum equation. We have sum of 20 terms, n over 2, which is 20 over 2. First term is negative 3 added to last term, which is negative 41. We just figured it out. Combine, so it's 10. Negative 44, and my answer is negative 440. And it does make sense. I see all negative numbers in this series or sequence, so if I add them all, for sure my answer would be definitely a negative answer, right? Okay, one last example. So pretend your first term, a sub 1, is 7. S of 40, I hope you remember the symbol. When I say S40 means I have sum of 40 terms, which is equal to 720. And I want you to solve for A40. A sub 40 means I'm asking you for 40th term. Okay. I can go back to explicit rule, but as an explicit rule, you have to have first term, which we already have it here. You have to have n minus 1. Yeah, which one we can do it here. But do we know the difference? So for a problem like this, explicit rule would not work. You have to find another way. So what is that? This is where I can use the sum equation itself. So I hope you remember again, sum equation for this S40. So I know I would do S40. So since I'm adding 40 terms, so I know number of terms, 40 in this sequence. First term 7, and a 40th, which is going to be my last term, is missing in this problem. And now if you look at carefully, basically it's an equation with 3 numbers given and fourth one is missing. So let's just plug in for what we know. So S40, which is already given in the problem, I'll just write it on the left side. 40 over 2, 7 plus A40. Almost there. Let's just solve for the missing variable, which is A40, this one here. So 720, 40 divided by 2 is 20. 7 added to A sub 40. So divide by 20 first. If I divide 720 by 20, it's 36. It's equal to 7 plus A sub 40. Solve for A40, so take away 7, and this is 29. So my last term, which is 40th term of this sequence, is 29. Yeah, this is pretty much all. So if you have any questions, just comment on this video. I answered that question. And yeah, this is pretty much all. So stay safe and enjoy the video. Thank you guys. Thanks for watching. Bye-bye.